Substitute the value of num, x, value of I, num into I. This is a loop. Basically what this does, first I will be equal to 1 and then the print is executed with num. Num if I say 7, 7x1 equals to 7 into 1. Then I becomes value 2, then you can see this. It's very easy to explain this to somebody who's new to programming, isn't it? You don't have to tell that person why you need hash include, why you need int main, why class, nothing. This is called succinctness. The language is succinct, to the point. It lets you focus only on the task at hand without extra boilerplate, without extra stuff code. And that is one of the biggest advantage of Python in comparison to many other mainstream programming languages. Now having said this, we look at the program's result with Python. 7 on the table, it works, no difference at all. If you try this with the table with 20 digits, it does not take. It works. You might now wonder whether the answer is correct. The only way you can confirm the answer is correct is, see this, 1, 2, 3, 4, 5, 6, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, into 10 is equal to the same number with one more 0 here. It works, right? You got it. So you can confirm that. Let me tell you, it's not just 20 digits, you put 100 digits, it will work. In a normal computer, you put 100 digit number, it will still generate it. So the language does not impose any limitations on the programmer about its CPU. So it lets you focus on your problem domain rather than having to worry about your CPU architecture or CPU limitations. Now you might ask me, why did the C program fail? Why did the C program actually fail earlier? The reason is because C language is written to be as low level as possible. It's meant for writing low level applications. So C is having the same limitation as the assembly language and machine language. All of your computer CPUs have their own internal registers. Suppose you have a program is then memory in RAM. Think of RAM as like a notebook. It's like a notebook where you have all the details written. Let's have like 10 phone numbers with the person's names, okay? It's in a book, a phone book. You want to dial up someone, you want to call some person by looking at the phone book. What do? You look at the person's name, you look at the number, early days. Today it's all in the mobile phone, you just click on all, it works. Imagine the early days we used to use landline. How many of you know about landline phones? Oh yeah. Oh yes, I haven't forgotten, right? Good. I think one more generation later people say, landline phone, what does it look like? Ancient grandfather's phone, right? They say that. So when we use the landline phone, we used to have a telephone directory where we look at the person's name and or a phone book where you look at the person's name and we dial that number or you type the number out, right? So then what we do, our brain cannot remember 100 people's phone numbers. So write it in a book. Whichever number we want to call, we will read that number, we note down the number and then we dial it. So our brain has got short-term memory. Right? Short-term memory, you can remember immediate quick events and will forget about it. A short-term memory will remember all the events that are happening right now. See, like what I'm speaking right now, now you'll remember. 5 minutes later, I'll ask you exactly, do you know what I spoke? You spoke something, but I don't remember what words you spoke. Right? It's a case with everyone. We will remember the overall things. The long-term memory will try to remember the context. Short-term memory, small words. If I tell you 10 words now and ask you to repeat, you'll repeat it now. 10 minutes later, you'll remember, not remember. Right? So, similarly, the CPU has got its own internal registers, which are called short-term memory. Why those registers are used? In your actual computer memory, there is a RAM, right? Your program is loaded. CPU will go and fetch that data from RAM. The program, right? Instruction read from RAM. And in the RAM, the instruction says, load this value in this register. You load that value in one register. Load another value in another register. Load another value in another register. Then add those two values in the register. Add it. The result is written back to RAM and it's forgotten. Right? It will be in RAM, but not be in the CPU. The register size, the size of the register in CPU is limited. Just like our memory is limited. That's why we write a lot of things in books. Why do you take notes? Because you can't remember everything. I tend to forget, so I can go back in the evening and recollect it again. So I make notes, right? So the RAM is more like that. And this computer memory or the CPU's internal storage or registers are limited. The size of the register in most CPUs determine the CPU architecture. you say 32-bit CPU. When I say 32-bit CPU, the register bit is 32 bits. You can store one 32-bit number at a time. Binary number. When I say 32-bit number, if you convert to decimal, the maximum value can represent 2 power 32. If you go beyond 2 power 32, you know what happens? All bits will become 1. All bits 1 in signed value representation will be -1. Right? That's why you see -1 when you put a very large number in the C program. Right? So this is a limitation with all these low middle level languages. Python, on the other hand, provides a higher level abstraction. Rather than treating numbers as something that can be stored fully in the CPU register, it uses logic, like how we do arithmetic on paper, right? Let's say if I ask you to add a 10-digit number with another 10-digit number, you can do it, right? Do we do it in your brain? No, we write it on a sheet of paper. We first read the units place, add it, carry over to tens place, add it, carry over to hundreds place. We do that, right? The same logic algorithmically is used by Python to perform arithmetic on very large numbers. That's why Python does not impose any limitation onto the program. Now you might ask me, can I not do the same thing in C? Yes, you can. If at all you want to write a program that can take arbitrarily large numbers in C or Java, the code can get even more complicated and not portable. This is a C program that does exactly what a 3-line Python program did. Well, and this program written in C will work in Linux, it will not work on Windows. That's a bigger problem. For Windows, the library will be different. It will use different functions. A lot of functions called MPC functions, you can see it. This works only as long as you use Linux. It's called GNU Mathematical Question Library, right? So it's called GMP. If you write in Java, though it's portable, so it's more boilerplate. You have to say big integer, noun is equal to big integer, a lot of boilerplate involved, right? So the point you can see here, what you do in these languages, in Python, is just relax. But does that make Python superior? No, not just that. Lot of complex problems can be solved in a most simpler syntax in Python. Now let me give you one more example. Let us say I have a list of numbers. Okay, before I go to the next thing, how many of you have worked on Python earlier? Okay, so a couple of Python users here. Okay, some of you are like thinking, well, raise your hand or not. Even if you wrote a print hello world, I can say you know Python. Okay, how many of you have done at least a print hello world in Python? Okay, now the hands are going up. Good. Okay, so we will say, do you know Tamil? I know only one. Then you know Tamil, right? It's like that. That's okay. At least we know, you say one thing, right? You at least know what it sounds like. Even if you speak one word in a language, you know what the language sounds like, am I right? Imagine trying to just speak one word in Chinese or one word in Thailand, in a Thai language. You tried it. You will realize how your tongue twists and how it feels. You get the feel of a language. Right? That's why I ask you, even if you say hello world in Python, at least you know how to launch Python and make it print hello world. Yeah, that's that. After that, it's all about vocabulary. Right? Now, if at all I have a list of numbers. In Python, many of you have worked on Python, would have heard about a list. What is a list? Yes. It's a sequence collection of items. It's a mutable sequence collection of items, more technically. When it's a sequence collection of items, what do you mean by that? It's a collection of values. Collections are like, I don't have many pins in here. Let's say I have one pin, I have another pin, and I have this remote control. And I have a microphone. All of these when I'm holding in my hand is a collection, right? All of these things. It's a collection of items. When I hold this collection in a particular order, now we can ask, give me the first item, I'll give you my Parker pen. It's a jotter pen. If you ask, give me the second item, I'll give you this this marker that is there. I mean this pointer, right? This particular screen pointer. The third item is the remote control, the fourth item is the microphone. So there's an order of items in it. That's what a list is. Now why am I talking about this? Because I want to show you a problem statement here. Now let us say I have a list and new interface, old interface. Alright, so here, let's say I have a list and Let me just type it out here. Let's say this is one of the ways you can create a list, right? This is a syntax for creating a list. Let's say from this list, I want to extract every alternate elements. I want to extract every alternate elements. I want to create a new list which will contain 10, 17, 34 alone. How do you think you'll do that? Yes? Very good. One of you mentioned slice. Fantastic. Think about it. If you are doing it in any other language, especially C or C++ or Java, you need a for loop. Or you need some special function that will implement a for loop, which is not part of the language standard library, right? But in Python, you can simply use this A of just equal to. This slicing operation lets you do a lot of acrobatics with managing list in Python. In fact, there are some examples I have here. Just a quick gist of it. This one. So if at all I want to zoom this and show you. You can see this. I have an example list here. I can access the first element of list by using A of 0. If I written the first element, A of 2 will return index 2, which is 33, which you can see here. If you want to access the last element of list, this was a eye-opener for me, because during the times in 90s time frame, right, 90 and 2000 era, when I was learning Python, I also knew Perl and C and C++, to some extent Java. So I already was conversant with many languages in programming. In no other languages at that moment, I could find a simpler way to access the last element of an array. If an array can find the last element, first I should know the length of the array. Somehow I should know what's the length. Then I should say length minus 1 as an index. But here, it is quite natural. You say I have minus 1. If you want to get the last 3 elements, you can use a slice. You can say you have minus 3 colon. Or you have colon 3. So you can extract slices of a list, the beginning, in the end, you can get alternate elements. Anyone knows how to reverse a list? Yes. You would simply say A of colon colon minus 1. So in many languages, there should be a function called reverse. You look for a reverse function to reverse some string and reverse arrays and all that. In Perl, I remember it is there. There's a function called reverse function, which is used to reverse a list or a string. But in Python, I couldn't find it. Oh, there is a reversed function in Python which does something else. There's an A dot reverse in the list which will reverse a list in place. But I want to make a reverse copy of a list. This is how we do it. And this not only works for a list, all these idioms, these slicing idioms, work for all sequences. So when it says sequences in Python, list is not the only one. Tuple, list, string. All of these 3 objects are sequences. When it says string, there's also another variant of string called bytes. And there's also another variant called byte array. There are 3 kinds of strings. You have str, string, normal string, then you have bytes and byte array. All of them are sequences. So these operators that we use, the square bracket operator with all these slicing, dicing operations, will work on all sequence collections, right? Without a problem. Not only that, there are a lot of really complex problem statements that can be solved easily in Python. One more biggest learning that Python that was there for me in Python is the use of comprehensions. Comprehensions apply map-like operation in a shortest possible way. So how do you do that? You can see here. I say A is equal to, I put 2, 6, 3, 8, 4, 9. The moment I say B into B, value to value, for each value in A, when I say, each of the values in A is multiplied by itself. And the resultant list will be all these numbers squared. It's a parallel map. You know, it's like doing 2 becomes 4, 6 becomes 36, 3 becomes 9, 8 becomes 64. So you can do that in the easiest possible way. In many other languages, you need to learn about functional programming idioms called map function with lambda expressions and all that. Python does have it, but you don't have to use it. We can simply use comprehensions. We can also apply filtering operations the same way and also do more sophisticated things like finding out the sum of it. Alright, so here I gave a very quick insight on how we can solve complex problems in lesser lines of code in Python. And this led to its popularity, and this is what made Python more widespread in the industry. So you can use Python for writing low-level programs that show you like in the embedded system, or you can write really high-end programs that run on supercomputers. Today, if you look at the field of data sciences and machine learning, Python is the chosen language there, because it's a language that can mold into various things, be it data analytics, data processing, or data visualization, or it can be building web applications and web-based dashboards, mobile applications, and also working with IoT devices. So this is one language that covers various areas of computing, and that's the reason why Python has become quite popular at this point, right? We are out of time, so I think it looks like we have a lab session. In the lab session, I'll give you some small experiments to try out, where I will teach you about some low-level stuff about fundamentals in Python again, okay? And we'll take it from there, okay? So thank you all. So good to meet you.